Thank you, Ian, and good morning, everyone.
Good morning.
Okay, how many of you got a mobile phone? Pretty much everyone. Okay. Well, first of all, please don't use it while we're speaking. But secondly, this is where I'm going to start, is when I was about the same age as you, and mobile phones didn't exist. About the most sophisticated technology that we had at home was a black and white television. So things have changed a lot over a relatively short period of time. So I'll introduce you to my mum and a black and white television. When I was your age, the thing that inspired my generation into careers in science and technology was the space race and the mission to land a man on the moon. So we're back into the 1960s when a US president announced the intent of putting a man.
We choose to go to the moon to Disneyland and do the other things, not because they are easy, but because they are hard.
So President Kennedy laid down the gauntlet to put a man on the moon before the end of the decade, and the decade in question being the 1960s. And I can remember sitting round a television watching the first moon landing.
Tranquility Base here. The Eagle has landed.
I am on the moon. Yes.
That's one small step for man, one giant leap for mankind.
And it was this incredibly captivating expedition that inspired a whole generation, and certainly inspired me. Now, I like to, this is the first man on the moon, raising the American flag. I like to have a bit of a quiz during the course of this little talk. So, it's a quiz with a prize. So, who can tell me what was the name, and you're not allowed to look at your mobile phones, what was the name of the landing site for the Apollo 11 spacecraft? And there's a prize of £5 to the first person to get it right.
Can you give me a hint?
Because I want to keep £5. Anyone got any idea? No budding astronomers. Go ahead.
Is it the Sea of Tranquility?
That's correct. Well done. The Sea of Tranquility. About to collect your prize. So now I've got your attention. There are two more questions interspersed into this talk. So what's all this got to do with the oceans? Well, the first man on the moon, well, the first two men on the moon, took a whole load of pictures, and one of them became an absolutely iconic image. It was the image of the Earth seen from the moon. And of course the thing that you notice about the Earth and the moon is that it's a blue planet. It is effectively covered in ocean. So more of the planet is ocean than is land, and it appears from space as a shining blue sphere. So planet ocean is what it really should be called. Now, it's about the same time there were inspiring things going on in the oceans, and this is one of those things. This was the construction by a very, very different mission to the mission to the moon. This was one man's inspiration to build a vehicle that could go to the deepest place in the ocean. He was a Swiss inventor by the name of Auguste Piccard, and he designed this machine here, the Trieste. It's effectively an underwater balloon with a little capsule underneath it, steel sphere here, in which two men could just about fit, and his goal was to take that vehicle to the bottom of the deepest point in the world's oceans. So here's the Trieste, this bathyscaphe being prepared for a dive. So effectively what you've got here is a big container full of paraffin, So it's very like a hot air balloon. Paraffin is buoyant in water, so it acts like a balloon, and it's carrying this little sphere underneath in which you can just about fit these two people. And here they are inside the sphere. Now you can imagine what this was like, very claustrophobic, and they're doing something that no one's ever done before. They're not connected to the surface, they're doing it in an environment which is extremely difficult to work in. So a pretty risky business. I've had the fortune to have met one of the two people that was in that sphere for that historic dive. And what you saw there was lead shot being released to make the craft buoyant to take it back up towards the surface. So they took that vehicle to the Pacific Ocean. And to a place called the Marianas Trench and to the Challenger Deep, which is the deepest place in the world's ocean. So here it is on that dive. And they took it way down into this trench, which is considerably deeper than Everest is high. So this is a very, very deep part of the ocean. And they took it right to the bottom, got to the bottom, took some photographs, lots of creaking and grinding as it was going down, so a pretty scary experience. It took hours to reach the bottom and hours to ascend back to the surface. And for a very, very long time, they were the only two people to have managed that feat of a manned dive to the bottom of the Challenger Deep. So now we've got another question. This is a bit of a hard one. It's a physics question. So the Challenger Deep is pretty deep, 11,034 meters. So it's much deeper than Everest is high. Now, how many of you are doing any physics? Right, so you were probably taught, at least in the early stages of being taught anything about physics, that essentially water is not compressible. But at these sorts of pressures, water is compressible. So the question is, how much deeper would the Challenger Deep be if water was not compressible? You're probably going to have to guess this one because it's a pretty hard question. Any guesses? Is there another £5 note going? Now I'm going to take a wild guess. Hmm?
35%?
No, give me a figure in meters. So is 11,034 is the measured depth. How much deeper would it be if the seawater was not very, very slightly compressible?
20,000?
No, that's a wild guess. No, I don't think you're going to get even close on that one. It is a hard question. It wouldn't be much, it'd be 36 meters deeper. So water's compressing just that little bit because of the great pressures at this depth to effectively make it shallower than it would be if water were not compressible. Okay, so now I'm going to bring us a little bit up to present day and look at some of the things that are happening in marine science and technology more recently. And I'm going to start with the business of man underwater again. So what you see here, this is back in about the early 1980s. You can see a one-man diving suit, so a diving suit, a one-atmosphere diving suit, being carried by a manned submarine. And then the diver being able to work away from the submarine, connected to it by an umbilical. So this is in relatively shallow water, nothing like the sorts of depths we're talking about earlier in the shallow to deep, but it's nevertheless in this sort of suit much deeper than you could go with conventional diving equipment. Now we're venturing into the Gulf of Mexico and exploration and production of oil and gas. And what you see here is an offshore structure and drilling into the seabed for oil and gas production. We're now in quite deep water in the Gulf of Mexico, certainly more than 1,000 meters. We're beyond the depth where you can realistically use divers to intervene underwater. So work underwater has to be done by some other way than putting people on the seabed. And the way it's done is using robotic vehicles, and you'll hear a lot more about those in the next talk, or one of the next talks. But robotic vehicles which can be lowered from the structure and can swim around under their own power, controlled from the surface, and do work underwater. And this is really like giant video games. This is real-life video games. The pilots are sitting on the surface, driving these vehicles remotely, and using them to carry out tasks on the seabed. Here's another manned vehicle. This is a vehicle called Alvin, operated by the Woods Hole Oceanographic Institution in the United States. It's a very famous submarine. It's made a lot of extremely important discoveries. It can carry 3 people, again in this case in a titanium sphere, and can dive to depths now of about 3,000 meters. And one of the discoveries that Alvin made was the wreck of the Titanic. So this is film taken from Alvin on the Titanic when it was first discovered in the North Atlantic. So can you imagine how the people on board felt when they found this? They'd be looking for it for a very long time. And that first dive on the wreck must have been really quite something. They also used remote vehicles, so you can see here a remotely operated vehicle being used to film inside the wreck. Another very important discovery that Alvin was involved in was the discovery of these features on the ocean floor. These are things called black smokers, and they occur all over the oceans, on the ocean ridges in the middle of the major ocean basins. And you can see what looks like smoke coming out of these structures on the seafloor. It isn't actually smoke, because we're now several thousand meters below the surface. It's actually superheated water that's circulated through the shallow geology of the ocean floor, and these are very volcanic areas. And this is superheated water that's dissolved lots of minerals, and so that's what's making it look black. And the amazing thing, which no one had expected and no one had predicted, was that they found that this was teeming with life. Now, no sunlight gets here, there are no plants, and all of the organisms that live around these black smokers live on the minerals that are being poured out of these plumes of hot water. So they're living on bacteria that are feeding on the metalliferous compounds coming out of these plumes of heated water. Now I'm going to take us back into space again, but this time into space from the standpoint of looking at the Earth rather than trying to explore beyond the Earth. This is the launch of a European Space Agency remote sensing satellite. One of the areas I do quite a lot of work in is satellite remote sensing. And we now have satellites in orbit that can make all sorts of observations of the planet. We've also seen the planet from satellites from much, much further away than that view of the Earth from the Moon. So this first image here is the Earth with its moon in the background, and that's taken from in the vicinity of Mars, about 86 million miles away. Again, you can see the blue planet. This is one of the most distant images we have of the Earth, and that's taken from around about the orbit of Saturn, so 800 million miles from Earth, looking back on the Earth, and again you can just about see that pale blue colour. But the area I'm most interested in is satellites that are much, much closer to the Earth. Satellites that are in orbit around the Earth, and they're using sensors to make measurements of the oceans. And we can make measurements of the temperature of the oceans, the height of the oceans, the colour of the oceans, the saltiness, the salinity of the oceans. These are all observations we can now make from space. Now, there's a big disadvantage to making observations from space. Satellites can't see what's happening below the ocean surface. They can only see the surface itself. So we need to also understand what's going on inside the oceans if we're going to be able to forecast the way in which they behave. And what you see here is an instrument being dropped from an aircraft. So you can see the parachute, the instrument attached. This is a thing called an Argo float, and again I think you'll hear a bit more about these later. So hits the surface of the ocean, the parachute detaches, and this instrument drops down into the ocean to a depth of about 1,500 meters and starts making measurements. Then every 10 days or so, this instrument pops back up to the surface. So here it is descending down into the ocean. This is a little tiny robot, really, a robot vehicle. It's drifting in the ocean currents, making measurements of temperature, of the salinity of the oceans, the dissolved oxygen in the oceans in the most recent version of these. So a whole variety of measurements. And then every 10 days, coming back up to the surface, transmitting all of that data back to the shore via satellite, and then descending again and starting another round of measurements. There are now more than 3,000 of these floats drifting around in the world oceans, making continuous observations of the internal structure of the oceans. And these sorts of robotic vehicles are becoming a major tool for understanding how the oceans work. This is going back about 5 or 6 years, and this was the first time that a robotic glider, so this is a glider under the ocean surface, made a transit from the United States all the way to Spain in one go without any intervention. So it took about 6 months to cross the Atlantic basin, making continuous measurements along the way. Here it is being picked up off the coast of Spain, brought to shore. Big welcoming party, because it was carefully planned that this glider, which is called Scarlet Knight, would land in Bayona. And Bayona is where the Pinta came back to Spain after the discovery of the Americas. So there's now a plaque on the wall in Bayona commemorating the crossing of the Atlantic by Scarlet Knight 516 years after the Pinta made landfall following the discovery of the Americas. Take all these different observations together, observations from space, all these measurements inside the ocean, and use a lot of numerical mathematical models, we can start to understand and predict the way in which the ocean behaves. So this is a pretty stunning image from a computer model, and it's showing false colours. So this is not the real colour of the ocean. This has been coloured to show the change in temperature. So this is colder water, this is warmer water, and this is all this warmer water eddying around the islands of Hawaii in the Pacific Ocean. Now, climate change is causing the oceans to warm. So how much do you think the surface ocean, on average, has warmed in the last 100 years? This is your last chance to win £5.
(1 degree Celsius).
Who was that? Hand up. 1 degree. Any other guesses?
10.
10 would be a lot. It makes swimming in the ocean a lot easier.
5 degrees Celsius.
4. 0.4.
5. 5 degrees.
I need to see who's answering, otherwise I can't. 5, and that was 0.4. 1.4.
Well, half a degree.
It's half a degree?
2.5.
Who said half a degree? Half a degree. Half a degree is pretty close, so you get the prize.
Thanks very much.
It doesn't sound a lot, but if you think about the entire ocean warming by, on average, half a degree, it's actually 0.59 of a degree, that's a huge amount of heat being stored in the ocean. So I'm going to turn to the opportunities in ocean science, and as a lead-in to the next talk. There are loads and loads of opportunities out there for you, for careers in ocean science and technology. This is an interesting one. This is a robotic fish. It's a fish that actually swims, but it's a man-made fish, and it has a load of chemical sensors in it for detecting pollution. So there's actually a swarm of these swimming around off the coast of Spain at the moment, making measurements in the ocean, and they behave like fish. They swarm, they shoal. So that's an interesting area. Other scale in engineering, this is a massive offshore structure being carried out into the Gulf of Mexico for installation. So again, that's a huge change in scale. Big engineering. This sort of exacting operation, the planning of taking this structure here, which weighs thousands of tons, and sailing it very precisely over these bases here, and landing it on them without breaking anything. Yeah, so some pretty challenging tasks to do in ocean engineering. Marine renewables, again, enormous scale. You'll hear a bit more about that later. Enormous engineering scale and some terrific career opportunities in offshore renewables, whether that be wind or, in this case, tidal stream. These are tidal turbines that are lowered below the surface to capture energy from a tidal flow. Understanding ocean climate and atmospheric climate changes. And what you see here is a change in ice cover in the Arctic measured from satellite. So some fascinating career opportunities in this sort of observation and interpretation of all of these data sets. Understanding the weather, being able to better predict these sorts of features. This is Hurricane Katrina forming over the ocean. Managing resources from the ocean, living resources from the ocean, so fisheries, all the fisheries science and all the technologies that surround fishing and aquaculture. And last but not least, protecting the environment of our oceans and seas. Again, you'll hear more about that in later talks. I'm just going to return for the last 30 seconds to that trip to the bottom of the Challenger Deep. As I said, the 2 people that went down in the Trieste, they held that record for a very long time. It was only broken on the 17th of March 2012 when Jim Cameron, the man who directed the film Titanic, who had built this vehicle, made a solo dive in this vehicle to the bottom of the Marianas Trench. Have I got time to just show a quick?
We're running.
Okay, I won't. I'll stick that to the end. Okay, so it's really an opportunity out there for all of you. Can you rise to that challenge? Thank you.
Thank you very much indeed, Ralph. We are running.